Hi, I'm Justin Hansen, and for the robotics final, our task was to program the doobot in order to be able to stack blocks both on top of and next to other blocks with an LLM parsing a user's input and creating the plan of action to perform all of the necessary tasks. And so in this video, I'm just going to show how mine works, the task that I had mine do, and um, like kind of what I should keep in mind going forward with this if I was to program this further, or what others should keep in mind if they are planning to do the same thing. And first and foremost, I am using Claude's API in order to parse the user's input, and it worked very well. I would recommend it. For this task specifically, as I'll get into later, I had the robot try and stack, as you can see here, each block in alternating color order on top of one yellow block that I specifically um, uh, identified as the one that I want it to stack on top of, the one that I told it to. And you can see how I saw that, as it'll pop up in just a second. I first have the program pop up with an image of all of the blocks that it detected. And so I picked yellow 11. That's the ID of the block that I decided to stack these on top of. And what I specifically told it is place all of the blocks on yellow 11 in alternating color order. And what I didn't realize initially is I forgot that I have to close the image in order to continue on with the code or with the program. And I kept it up for the video, but I'll in a second here, once nothing happens, realize I forgot to close the image and I just didn't read. But it saves, like, what I just entered will still go into the program. It'll remember that I asked this. It's just that the program paused before I asked that. These are all the blocks that it detected. It just heard my command. I didn't have to type it in here because I pressed enter earlier. But right now it's asking Claude, and here is what Claude determined should be the plan. It's saying the action it's going to take, whether it's a pickup or a place, the block it's going to pick up, and if it's placing, then it says the block that is currently held, the block that it's going to place these onto, and what kind of placement it's going to be, whether it's on, left, right, above, below. And as you can see here, it started with that red block, and it's going to the blue, and then it's going to go to a green. And I picked this to be my prompt because I thought it showed more of the freedom for the LLM to kind of choose what course of action to take. And I thought that it would be a bit more interesting than just watching blocks be put back onto the paper right next to other blocks, and it would look like not much changed. This is a very clear representation of change being done to the layout of the blocks. And it also shows how the higher the stack is, the program accounts for that. And the way I did that was I keep a record of how tall each stack of blocks are. Initially, it's just one for everything. And when I place blocks, I have it set to the placement height being the table height plus the tower height times the block height. So because the tower is now 5 tall, it'll place it at table height plus 5 blocks height. And as you can see, it places it pretty accurately. And I assume what you can already tell is going to be a problem is that one green block in front of the stack has not been picked up yet. And the taller this tower gets, the less likely it is that it will be able to pick it up. And the end result is what you would expect. But overall, the plan was pretty accurate. And the some things that I had trouble with was the rotation of blocks. I didn't realize that positive rotation for the robot was counterclockwise, which makes sense thinking back at it. But what OpenCV sees when I detect the blocks and look for the orientation of rectangles that I detect is it detects the angles the opposite way. So when I try to rotate the blocks that are held to match the angles of the blocks that are currently down, it rotates them improperly. And here, I knew this was coming, and I just show how it gets stuck there, doesn't pick up the green. Now I pick up the green just because it would have worked, and I want to see it complete the stack. Um, and now it thinks it's placing the green, and now it's going to continue on. However, that one hiccup is something to look out for. Other times after this attempt, I tell it pick up this block first, um, and it'll implement that into its code in order to. But that's what the user has to do. Something I could do is in the prompt, I could say, um, things to remember: pick up the closer blocks first, as to not knock over a tower or slam into a tower when um, completing a tower. And that's basically it. Um, the way that I get the Claude response and parse it is I have the AI return a JSON with um, the reasoning that it had and then each action that it wants to take. In my program, I have a bunch of pre-made functions for picking up, placing blocks, rotating blocks. The prompt given to the AI contains those. It's saying, "Hey, here's what you can do," and uh, these functions perform these actions. So you should keep this in mind when preparing your plan of action. And when I take the JSON response from the AI, I just take, if it says pick, then I'm doing the pickup action. If I'm placing, I'm doing the placement action. And it also tells me which blocks these are being performed on, the block IDs of them. And so I just take those block IDs that were provided and put them in the functions. I perform the functions with that. And the AI is also given the block IDs, which are all stored in a library. Once OpenCV detects blocks, it detects anything that is a rectangle of a specific size or a general shape of a rectangle. That way I don't catch like any green glare from the window or any odd shadows that might be there. And I keep this library of blocks, their IDs, and I keep their positions, their rotation, and their stack height that they're currently at. And this all gets fed into the AI. It sees this and it thinks, okay, I have these blocks to work with. They are these colors, and as stack heights grow, the algorithm itself just increases the height of each block in the library that is in a stack.